Welcome to Keysight's new compact 8500B FE-SEM, now with optional energy dispersive spectroscopy capabilities. This easy-to-use plug-and-play scientific instrument delivers low-voltage imaging with less than 10 nanometer resolution and exceptional surface contrast. There are no special facility requirements for installation. Only a normal power source is needed. The 8500B offers several unique features. Continuously variable voltage from 500 to 2000 volts allows high-resolution surface imaging of energy-sensitive samples or samples that tend to charge in the electron beam. Implementation of patented miniaturized technology provides analytical SEM performance in a remarkably compact form factor. A novel column design delivers high brightness, small spot size, and excellent stability during imaging. Optional, fully integrated energy dispersive spectroscopy capabilities enable qualitative and quantitative elemental analysis. There are no special sample preparation requirements for the 8500B, and typically, you don't even need to coat samples for imaging. A programmable stage allows you to easily find regions of interest on the sample or move between samples if multiple samples are loaded into the instrument. Changing samples is fast and easy, with pump-down times of less than 3 minutes. A sample height safety checker helps prevent damage to the instrument by automatically pointing out any samples that have been incorrectly loaded. The 8500B enables quantitative elemental analysis to be performed on a selected area, line scan, single point, or multiple points via energy dispersive spectroscopy. You can select standardless quantitative analysis, analysis with standards, or a combination of standardless and standardized quantitative analysis. Event stream spectrum imaging saves the full spectrum at every pixel for analysis and display. I would like to demonstrate EDS analysis operation using an uncoated table salt sample that is attached to conductive carbon tape. We are currently viewing the sample at 2 kV. We can precisely set the magnification by selecting the Zoom button, right-clicking on the Zoom button to bring the Field of View dialog box, and entering the field of view. To set the magnification to 1000 times, we enter 204.8 microns. The EDS control parameters are located at the bottom of the EDS tab. The first step after focusing the image is to set working distance by pressing the Set WD button. This places the sample at the proper Z location so that the EDS detector is aligned to the analysis area. For this analysis, we will operate at a 12 kV landing energy. The EDS bias is user selectable in the EDS bias pull-down immediately to the right of the Set WD button. To enable the sample bias, you check the Enable box. Note that the column voltage and landing energy is displayed at the bottom of the image window. We are now looking at a backscatter electron image obtained at a 12 kV landing energy. The 8500B EDS features include the ability to perform several different types of EDS analysis, including probe, line scan, and spectrum imaging modes. For this demonstration, we will use the probe mode. In the probe mode, we have 4 different options. Full raster provides a spectrum of the entire image displayed. Reduced raster allows the user to select a specific area within the image. Single point allows the user to select a specific point. Multiple points allows the user to select multiple points for analysis within the image. For this analysis, we will select Reduced Raster. The user can also select timing or count parameters to determine when the EDS analysis completes. In this analysis, we select Live Time and have set the total time to 300 seconds. Here we are selecting the area for EDS analysis by using the left mouse button to draw a region we wish to analyze. The final step is to start the analysis by pressing the Start button. Here we are showing the second monitor screen. This is the EDS screen. After we press Start, a reference image is set to the EDS screen and a live spectrum starts to show in real time. The spectrum image is set to auto scale so that the maximum peak appears at 80% of the full vertical scale. A feature of the Keysight 8500 EDS system is that analysis can be performed in real time without having to restart the EDS data gathering process. Here we are in the Element ID tab and can select the Peak ID function to automatically tag the element's presence in the EDS spectrum. The sodium and chlorine peaks are being automatically identified. I have turned off the Auto Peak ID and have moved to the KLM Marker Lab. I manually select the chlorine and sodium elements from the periodic table and their markers appear on the spectrum. We are now nearing the end of the selected analysis time of 300 seconds. I reselect the Element ID tab and select Peak ID. We see that there are also small peaks for carbon and oxygen. Note that this is a table salt sample and contains other impurities besides sodium chloride in the form of anti-caking compounds such as sodium aluminosilicate. I have selected another reduced raster area on our sample and have restarted the EDS analysis. In this area, we begin to see other peaks besides sodium and chlorine appear. I have selected the peak ID to see what other elements these peaks consist of. The oxygen and silicon are becoming apparent. I've moved back to the KLM marker tab and am manually selecting the silicon and oxygen markers. We're coming to the end of the EDS data gathering time. We have this small peak to the left of the silicon line. Since we have some knowledge of the sample, a good guess would be that this peak is from aluminum in the sodium aluminosilicate anti-caking agent. We have returned to the SEM image monitor screen. I am now selecting the Spectrum Image EDS mode. I have set the frame count to 5,000. This means 5,000 scans of the image will be used to perform the EDS analysis. I can manually select the number of sample points that will be used to construct the EDS spectrum image from this pull-down menu. Since the effective probe size is approximately 1 micron at a 12 kV landing energy due to the probe interaction volume in the sample, I choose 128 by 128 sample points for this 200 micron field of view. I have moved back to the EDS monitor screen. We see the spectrum starting to build as we did in the probe mode, but now also have several element window on the left side of the monitor screen. While the EDS events are being gathered, we can customize the element window in real time. We can select which elements appear in this window without having to restart the analysis any time during or after the EDS event gathering. This includes which elements we wish to see a spatial map for and what other images we wish to see. We can also select the Element ID tab and auto-identify the element peaks and also get an estimate of the quantity of elements present. We are performing an EDS analysis of this full image. I am manually selecting the KLM element markers just to confirm the element peak auto-identification based on what I know to be present in my sample. Auto ID of peaks is confirmed. In the Element ID tab, we can force a peak ID by clicking on the element if we positively know that it is present. The element then appears in green in the periodic table. Likewise, if we have a false positive of an element being identified that is known not to be present, we can click again to turn the element marker red. Beryllium and boron are turned off in here since they lie below our detectable limits. I am looking at the element quantities present in this analysis. Welcome to the low voltage software overview for the 8500B field emission scanning electron microscope. In this segment, we will present some of the basic software functions that come standard with the 8500B as we look at a sample of non-pure sodium chloride crystals, typical of those found in salt packets at restaurants and cafeterias. We begin in the low magnification view with one salt crystal located at the center. The 8500 software allows us to measure feature sizes or the field being viewed, which is currently about 930 microns. The software also provides several easy navigation methods, one of which uses the arrows located in the center section of the stage control. Another ease of navigation feature is the ability to set coarse, medium, and fine steps for the 8500B's standard motorized stage. There is also a locations feature and a navigator feature in the software. The navigator feature lets us select where we would like to drive on a standard 25mm stub, or in the case of a multi-sample stub, there are 4 different locations for smaller 12mm stubs. We can simply drag and drop to those locations, and the system will automatically move the stage accordingly. Currently, we have moved several millimeters to the upper right, so now we are going to move back to roughly where we started. We can speed up the scan as well, which is helpful for coarse navigation. The stage can also be moved by dragging the cursor on the target diagram. The farther the cursor is from the target center, the faster the stage will move. Alternatively, The software's point and move feature moves the stage so that wherever the mouse is clicked will become the center of the field of view. The software also lets us adjust resolution, changing the number of pixels that are sampled in both the horizontal and the vertical directions. Now, let's point and move to an individual grain. Another control capability of the 8500B software allows us to manually zoom in on the region of interest, or by simply right-clicking on the zoom button, we can manually set the field of view and therefore set the magnification to a predetermined value. We are currently in the low magnification view, which is an aid for navigating. To increase resolution, we will now go to the high magnification view. Once we find a region of interest that we would like to view at a higher magnification, the stage, which is motorized in Z, will bring the sample closer to the electron column. Next, we will zoom out a little bit. And again, we will use the point and move feature to center the region of interest. In order to aid quick focusing, a new feature in the 8500B software allows us to use the mouse to select and zoom in on an arbitrary area and then use that area to fine-tune the focus. Now, we will return to zoom and increase the magnification to a 64 micron field of view, which gives us roughly a 3200 times magnification level. Again, we can continue zooming in. If we want to set the magnification to a known value, we can simply set the field of view directly to a magnification level, for example, to 10,000 times. Once again, we can select an area to use to perform focus. By right-clicking on the focus bar, we can utilize fine focus. One advantage of the 8500B is the ability to choose a landing energy to mitigate charging artifacts. This is done via the software's advanced screen, where we can select a beam voltage continuously from 500 to 2000 volts in order to minimize charging effects. We can either drag the beam voltage slider bar, or if we know an exact voltage we can go to, we can hit the Alt key, right-click, and manually set the voltage. Here, we will set the voltage to 800 volts, return to basic zoom out, and refocus. We had some mild charging artifacts, which are now gone due to choosing the lower voltage. Next, we will go back and zoom in on our region of interest. There is also a fixed central half feature, in case a specific region does not need to be selected. Now, we will return to zoom and set our magnification to the desired value. Note that the 8500B has several different detector modes. The system utilizes a 4-channel MCP as its detector, and we can choose between normal mode, which uses all 4 quadrants of the MCP, and various topo modes. Topo 1 mode uses the 2 left side quadrants of the detector, thereby providing us with a different perspective on the sample. Topo 2 mode, on the other hand, uses the 2 right side quadrants of the MCP, and now we will return to normal mode. Another standard feature of the 8500B is that it can detect secondary electrons or backscattered electrons, which can provide contrast when the atomic number of the sample varies greatly. Currently, we are using the secondary mode of the detector. The 8500B also has a new image tiling feature that can be used in conjunction with stitching. This new feature allows us to assemble a number of rows and columns. The tiling feature automatically recommends the step size based on our current field of view. Now, as an example, we will instruct the 8500B to gather 2x2 images around the origin, which is the center point. We can also auto-name the set. A number of built-in system checks provide the operator with guidance to ensure proper setup. After all the images have been saved, and we will be able to use them in a separate stitching program to assemble a larger field of view. In summary, Keysight's new 8500B FE-SEM software provides unrivaled ease of navigation features, enhanced contrast modes, and smart tiling capabilities to facilitate low-voltage imaging on a wide variety of materials. The Keysight 8500B Compact FE-SEM offers less than 10 nanometer resolution, fast and simple installation, thanks to a clever plug-and-play design, continuously variable low voltage for imaging energy-sensitive samples, consistent, repeatable performance with no special sample preparation requirements, with a motorized stage that lets you quickly transition from loading samples to getting data, and now, fully integrated energy dispersive spectroscopy capabilities for quantitative elemental analysis.